Yeah. Good evening, everyone. Switch camps. Let's start off. Did everyone try this homework question here? Any answers for this? Others, you need to keep your cams on. Abhinav, answers. Aditya, Yasha, Swastika, Anusha, Anika, answers for this. Hazrat, Niranjan, Rehan, anyone answers for this? Neil, Vidyut. There are 4 parts. Anyone got any 1 or 2 parts? How do we proceed with this? Okay, let's see. Where are the rest? Again, why so many people are absent? Try, think for a minute. I'll show you how to do this. Hope everyone has given the test. If you found any errors or corrections, do let me leave the message. I'll be posting the results by tonight or tomorrow afternoon. Let's see how to do. Now, in these kind of questions, right? Remember, it's this kind of things you'll see a lot. The word is this: constant speed or constant acceleration. These are the words. Whenever you see the question, these are the words, which should give you a kind of like, okay, this is how I start the problem. So whenever you hear the word constant velocity or constant acceleration, now see, these are not concepts, what I'm saying you right now. One second. Okay, guys, I'll just start kicking you guys out of the classroom. We'll start with people whose name starts with A, then B, then C, and then Z. There is no one with Z. Okay. Ronak, you need to keep your cams on. Yeah. So now this thing, right? What I'm saying, constant velocity. When any point or any object or system goes with constant velocity or constant acceleration, let the observer be on that system. Means you solve with respect to that frame. Now see what happens with this. If you look at the first part here, this is the block M. This is point A here, and this is going with U. And this was initially at rest. So I'm asking you to solve with respect to A. So keep your observer on point A. So what will the observer think? I am at rest. And he will think the block has got speed U. Make sense? That's what he thinks, right? In his frame. So it feels like now the point A is fixed and the only block is oscillating. And I always tell you, define your initial and final state. Eventually, when the spring is elongating, this is point A. This block comes to rest here. Let this distance be x. This is your state 1. This is your state 2. State 1, spring potential energy, 0. Kinetic energy, half mv square. State 2, spring potential energy, half kx square. Kinetic energy, 0. Now, can I do this? Meaning you need to ask, what is the problem in doing this? Since A is going with constant velocity, there's no pseudo force also. A is going with constant velocity, or you can, since velocity of A is constant, there's no pseudo force. So this is also an inertial frame, so there's no problem as such. Since there are no external force on the system, energy in state 1 is equal to energy in state 2. Half mv square is equal to half kx square. One step ka answer you will get it if you stand on A. X is equal to m by k cut root into v. Check. So the main idea is, since it is going with constant velocity, in the ground frame, it is pretty complex to understand. It is moving, oscillating, everything. Just stop that stupid point A, na, it will be fixed. So okay, only the spring is, no, only the block is going left and right. It is more easy to study that. And you can do this because the A is constant velocity. Is the logic clear, everyone? Now see, if how to do this, now this is not a physics concept, right? That whenever you stand on A, it becomes easy. This is not a physics concept. This comes from experience. When you solve a lot of problems, when you see a lot of things, you'll figure it out. Right? Something is going with constant velocity. Let me stand there. Keep this in mind. We're going to do a few more problems on this today. You'll understand. Constant velocity, constant acceleration. Just go and stand on that. And most of the times it becomes quite simplified. This you will not understand by reading books. These things you will learn when you solve problems. There's nothing there. There's no one concept. Work done by external forces change in E final minus E initial. That is the only concept we have. We are just playing around with it. Please check this out. Ask me anyone is confused with this. This is the first part. What was the second part? Find the maximum speed of the block during the motion. Can you try? I'll give you a minute. Using from here, can you think of something? Find the maximum speed of the block during its motion. Now, since I didn't mention anything, it is always in the ground frame. Understand that. If nothing is mentioned, it is always in the ground frame. We have 2 people missing. Rian is missing. Who is the other person? Any doubts on this first part? Please ask me. It's a good one. Anyone? What about the speed? Any answers on that? Can I turn the page? Now, see, second part. Now you went there and you stood on this point A. So he will think this block is oscillating with you. If you look at this motion here, this block will go to extreme position. Again, this block will come back here. So this will come to rest. This is at extreme position. This is at mean position. When it comes back, again, will come back with speed u. Right? And then if you observe this thing now, this will again compress here. Again, it comes to rest. Again, stops. So it will just keep on oscillating left and right. So velocity of the block in the ground frame is velocity of the block with respect to A plus velocity of A in the ground frame. So this is velocity of the block with respect to A plus A ka velocity is always u I cap. That is constant. Agreed? Now you tell me, when will this be maximum? First of all, when do you get maximum speed? You get maximum speed at the mean position. Agreed? We get maximum speed at the mean position. Now you tell me, if I take this case here, what will happen? This will be minus ui cap plus ui cap, 0. If I take this case, that is when the block is coming back, what will you get? We get plus vi cap. So this velocity, this value, right, varies from minus ui cap to plus ui cap. Now you tell me, what is the maximum possible value? Therefore, max value of block is 2u. Is that making sense? That block is going away from me with you, comes back towards me with you, and I myself going with you forward. So the maximum velocity will occur when both of us are in the same direction, isn't it? If both are going opposite, they'll cancel out, but both are going in the same direction, they add up. Do check it out. Any doubts on this? Anyone not convinced with this logic, please ask me. Because A will think the block can go away from me or can come towards me. So the value can vary from minus u to plus u. And the egg is always going with you forward. When both are in the same direction, get maximum velocity. So during the entire motion in the ground frame, the block velocity can go from 0 to 2u. Clear? Huh, Ronak? Aditya? Getting this? Maulika? Neil? Arjun? Vartika? Clear with this? Adrit? Yasha? Aryan? Perfect. What is the third question? Find the work done by external force when the spring is maximum elongated. This case we are talking, when the spring is maximum elongated, what is the work done by the external force? Remember that A is going out, it is not going on its own. Someone is pulling point A from outside. Now we don't know how much is that guy, we don't know who is that guy, but someone is pulling it. So the question is, when the spring is maximum elongated, how much work did this guy do? Now I think you got enough idea what is happening with this problem. Take a minute or two. And what is the fourth part? If the block is pulled with constant acceleration, find maximum elongation. Now can you try C and D part? I'll give 2-3 minutes. Try. I think it didn't strike that you can stand on A and solve. That is the main idea in the problem. And remember that whenever you hear the word, a car is going with constant acceleration, what happens to the block inside? Just go and stand inside the car. Something is going with constant velocity, what happens to this? Go and stand on that. And this was not the first time, you have done this before, you just don't realize it. We have done this in laws of motion. Do you guys remember this problem? Relative velocity. We just went and stood on the point A, and this felt like it is going with you. Do you remember this question? A is going left and C is going right. So what did we do? We went and stood on point C. And what did C think? C think A is going with 3u and this block is coming down. And then we just added the velocity. This technique, we used it in kinematics for the first time. There we didn't realize it, but there, this was the logic there. Try. Should I show any page? Please let me know. You want to see this page or this page? Hope all have given the exam. I even gave a reminder in the middle. There is an exam, please give it. And people still forget. Work done by the external force when the spring is maximum elongated. What happened, Ranisha? Today you're dull, tired. Nothing. You're just serious. You look little, I don't know, you're not so happy today. Chalo, solve. You should just eat some Nutella, you'll be fine. How we do this thing? Ali, just switch on your light. Huh? It's just too dark. You're not playing any games right now, so do switch on some lights in your room. Show you the third part. Any answers? Why everyone is so dull today? So the work done by the external. This is a good question. That is the reason I gave it as a homework and gave you time to think about it. The work done by external force when spring is maximum elongated. Now, in the ground frame, when spring is max elongated, velocity of the block is equal to velocity of A. A thinks block is at rest now. There's no relative velocity with respect to a block is at rest. That means if you see this in the ground frame, this is the scenario there. M, this point is going with you, and this guy is also going with you, and this elongation is x max. Oh yeah. Work done by external force is change in potential energy plus change in spring energy, kinetic energy. So change in potential energy will be half k x max square. Change in kinetic energy, A has no mass, so that is gone. Initially, block is at rest, so half mu square. And half k x max square is nothing but half mv square only. So this would be half mu square plus half mu square. Mu square. That's your answer. Is that making sense? In the ground term, if you observe, both the blocks are going with same velocity. Look at this thing. When do you get maximum elongation? When A thinks block is at rest. Matlab kya? A and block are going with same velocity. So relative velocity is zero. Both have same velocity there, and the elongation is also maximum. Work done by external forces change in potential plus change in kinetic. Easy. What about the fourth part? What happens when the point A is accelerating with constant acceleration? Now what to do? Now again, same story. You stand on the point there. If you just go and stand on point A, we apply a pseudo force. Now listen carefully. There is something important here. Most people goof up this part. What these people do, they think at some particular point, the spring force, this will become kx, this will become equal to ma. They think kx is equal to ma is the maximum elongation. This is not maximum elongation. This is not max elongation. Reason, at this point, if you observe, since at at this point, right, if you observe ma is greater than kx, the block is speeding up. Block is not going slowly. Block is going faster and faster. So at this position here, the block has gained maximum speed So here at this point, you have maximum speed. Net force is zero, agreed. Acceleration is zero, but the block speed is not zero. So the block won't stop here. It will continue to go further. Max speed is there. You're getting it. Block will continue to go further. So the common mistake, what people do, they think the equilibrium position is the maximum elongation. It won't stop there. Think about it. When you leave a pendulum at the bottommost position, velocity is zero. Why won't it stop there? Why will it oscillate? Because at the bottommost position, it has gained maximum speed. So at this position here, you get zero. This is X max. This is a pseudo force. So initially velocity is zero, finally velocity is zero, and we can write work done by external force plus work done by pseudo force is change in potential energy plus change in kinetic energy. Pseudo force का work done is ma, x max, force into displacement, ma is constant. External force work done is zero. Change in potential energy is the spring force, half x square max. Kinetic energy is zero initially, final initially. So we end up with x max will be 2 times ma by k. And you'll observe this answer will be always 2 times the mean position. You get double. Check this out.
Can you show the C part for a minute?
Hmm.
Yes, sir. Thank you.
Clear? Any doubts on this question? It's a pretty good one. So you're pulling with constant speed, you're pulling with constant acceleration. It works out. Can I go ahead? Next one. Has a lot of concepts in this. So do give it a try again on your own today. Ideally speaking, class gets over. If you can do it today after your dinner or something, it'll be great. Instead of waiting for next time, if you do it on the same day, it is better because next day you'll have some other thing to do. Let's see this one. This is another good one. So we have a particle mass m. This point is fixed. This is a string, and this is a length L. And then this is just rotating with an angle theta. Pendulum is released horizontally. Horizontal position. Gravity is there. First question. Find speed. A centripetal, A tangential, tension in the string when it is rotated by theta. B part. Find theta when the net acceleration becomes horizontal? If the string can withstand maximum tension 2 mg, find theta when it breaks. There, we are combining work per energy with circular motion. Let's get this. I hope the question is clear. We have a pendulum released from horizontal position length L. It's just swinging like a regular pendulum. Find the speed, centripetal, tangential, tension when it rotates with theta. Find theta when net acceleration becomes horizontal. If the string can withstand maximum tension 2 mg, at what angle will it break? Try. The answers. The first part was easy. Try. I'll give you a minute more for the first part. mg cos theta, g sin theta. Okay. See the first part. So if you look at this height here, if that is theta, this is L sin theta. So we can simply write loss in potential energy is gain in kinetic energy. So at this point, this is the velocity v here. Loss in potential energy is mg. L sin theta is equal to half mv square. V is equal to root 2 gl sin theta. There I got the speed. Second thing, you ask me for tension. So if you ask for tension, there's only one way to do. You have to draw a free body diagram. So if you draw a free body diagram, the forces are tension, mg, and you are going in a circle. So there is a centripetal acceleration and there is a tangential acceleration. If this is theta, this will be 90 minus theta. So this component will be mg sin theta, mg cos 90 minus theta, and this component will be mg cos theta. I hope the components are clear. And then if you write the forces here, T minus mg sin theta will be mass into centripetal acceleration. What is a centripetal? V square by L. This will be 2g sin theta. That's your centripetal acceleration. So T will be mg sin theta plus ma centripetal, which is m2g sin theta. So tension in the string at any instant is 3 mg sin theta. So you can do the D part of the question here only. If you say this should be less than or equal to 2 mg, so when it breaks, tension is 2 mg. That is the maximum tension you can have. So 3 mg sin theta is equal to 2 mg. So sin theta is 2 by 3. There we got the D, C part answer also. And what is A tangential? Mg cos theta is m into A tangential. This is one part and this is one part. This is one equation here. And A tangential is G cos theta. And this is the second equation here. So I hope that is clear. To look at the equations there. So we are writing equations in this direction and equations in this direction. So you have treated these things as x and y along the string and perpendicular to the string. These are equations along the string. I think you got that point. Do check it out. So the main thing is conserve energy, get the velocity, and then draw the FBD, resolve the components. Since you're going in a circle, there's a centripetal and a tangential. And there you got it. Please ask, anyone is not convinced with this. And the second part of the question is find theta when the net acceleration is horizontal. But first, let's be clear with this. Any doubts? The second part of the question, find the theta when the acceleration, net acceleration is horizontal. Any answers for the second part? Two try. Find theta when the net acceleration becomes horizontal. I could have asked you this question also. Find the theta when the acceleration is vertical. I can add that question also.
So,
Hmm.
for the velocity, could we have assumed the initial position to be the 0 point line? And initially, it should be having some. Achha, no, it's wrong.
Here we said what is released from horizontal position.
Yeah.
Aditya, you are right. Others try. Find theta when the acceleration is horizontal. Net acceleration. Remember, net acceleration is acentripetal and a net acentripetal का resultant. A tangential and acentripetal. See. At any instant here, if you look at the acceleration, this is a centripetal, this is a tangential, and you want this guy to be horizontal. So this is theta. So this is also theta. So we get tan theta is equal to the opposite side, a tangential by a centripetal. And what is a tangential? G cos theta. What is this thing? 2g sin theta. So we get tan square theta is equal to half. It is not half, right? What, Zanika Aditya? Check your answers. 1/√2. A centripetal and a tangential also depend on theta. This is one way to do. Or you can also say in this direction the component should cancel. This will be a centripetal sin theta should cancel with a tangential cos theta. Since the acceleration is horizontal, vertical component should cancel. You get the same answer. You could have done that also. Why do you take theta as 45? If theta is 45, question is over, right? Answer is 45. I'm asking you to find theta and you assumed it to be 45. Doesn't make sense. Isn't it? And when can someone tell me when will you get vertical acceleration? That would be a good theoretical question though. Find the instance when the vertical acceleration is when the acceleration is vertical. Anyone? At what angles will the acceleration be vertical? Yeah, Ajit. There are only two positions, huh? One at the initial position. A tangential is G, a centripetal is 0. The second position is when you're vertical. A centripetal, and at this point A tangential is 0. So at theta 0 degrees and 90 degrees acceleration is vertical. Theta 0 में it is tangential, theta 90 में it is centripetal. At only these 2 points, right, you get vertical acceleration. Clear? That would be an easy question. Do check this out, everyone. 180, 180 also. We're just taking theta to 90 tak, so yeah. Do have a look at this.
So can you show the first part for a minute?
This one?
Yes, sir. Thank you.
Clear with this, everyone. It's a decent question. It's not tough one, but it's a decent one. Next one. Turning the page. Any doubts so far? Please ask me. Let's see the next one. We have a block M here. We have a block 2M here. String constant is gain. Okay, initially the system is at rest. Alright, in pace में they finish work per energy or still going on?
We finished.
It's still going on, sir.
No, it's still going on.
Not for the 3-year program, for the 2-year people.
No,
Still
Yeah,
going
for
on.
the 2 year only.
we finished. It's going on.
Okay. Yeah, they still have time, no? I think after this they'll be starting 2 chapters, 2 tracks.
Yes, sir, from next week.
It is nothing. Don't get really scared. You know, you're having 3 classes, they'll make 4 classes. They'll keep 2 classes. They'll just increase 1 class. And that is actually more messed up. But we will keep going only 1 chapter at a time. But we'll be ahead in 1 track. We'll lag a bit. But by major test to major test, we'll finish other portion. Don't worry about that. So now look at this question. So initially system is at rest. Then what happened? Someone pushed the upper block. By some y. So the upper block is pushed down by y and released. Are you able to visualize how it is? You're pushing the block down and then you're releasing it. And then what will happen? This block will start coming up. So there is a possibility this block, right, after leaving this will fly off in the air. It loses contact. Lower block just loses contact with the surface. I hope you're getting the scenario what is happening. You have a spring block, you're pushing it and you left it. So when this thing is oscillating, there is a chance the lower block lifts off the ground. So the question is, find the y minimum if the lower block just lifts off. Meaning it just left contact with the ground. Is the diagram clear? 2 blocks, M, 2M with a spring. Whole setup is vertically placed. Initially is at rest. Someone pushed that upper block by y down and then released. And during the motion of the upper block, at some point, the lower block lifts off the ground. Find y minimum. How do we do this? How do we do this? Palaksh, do switch on your lights in the room. It's too dark. It looks like Batman ka movie. Why is 2mg by k? Okay. Someone got 4mg by k. If someone has mucked up the answers from some other question, that's what happens. Let's see. Solve. 4mg by k. Now I don't know the answer. Even I have to solve. Let's see. Others try. Let's see. 4mg by k. Okay. Now, first of all, try to understand why this block is lifting off. First of all, tell me one thing. Is the spring in natural length? Initially, the spring is not in natural length. It is already compressed. Like I always say, work per energy mein, the most important point is to draw your final diagram. In laws of motion, the most important thing is to draw your FBD properly. If you know how to draw your FBDs properly, if you know how to draw your final state properly, and to draw the final state, you actually need to think. And let me tell you, 50% of the problem is over there. Most people goof up physics because they can't visualize what is happening. Right? You should know how does the final scenario look like. That is a major problem. And it takes time. You need to, consciously think about that. Okay, what is happening now? What is happening now? Karke. You need to keep asking. But what most of us do, we just, keep staring at the question and think like somehow the answer will come on its own. And brain doesn't like when you ask too many questions. Not your problem. That is how we have evolved. And that's why you need to get out of the mold. So this was your natural length. And this thing is initially compressed by, I'll just call it x1, which is mg by k. So spring is not in natural length initially. How did I get this? Kx1 and this is mg. Then what you did, you compress this block further. Now this whole thing became y plus x1. This is your state 1. Your problem starts from here. And then the block will come to the position again. You'll go to the natural length. That is fine. Now you need to understand one thing. As long as the spring is compressed, the lower block will never lift off. Here, if you see, the spring is still compressed. It still didn't reach the natural length. If you look at the forces on the body, the weight is 2 mg. This is niche kx. So when the spring is compressed, the lower block will never lift off. So if you want to lift off the block, the spring should have been elongated. The lower block lifts off when spring is elongated. Because you need to pull. So in this scenario, the force will be like this kx, and this guy will be 2 mg, and you're just lifting off. So normal reaction is n is just 0. That means this length here, x is given by 2 mg by k. This is your final state, everyone. This is your state 1, and this is your state 2. This is the actual way of, this is how you actually supposed to solve. You need to think what the hell is happening. If you directly jump into, writing equations, find that, this, maybe you will get answer for this problem, but going ahead, right, your subject will be pretty messed up because you're not learning it in a proper format. It's like, going to a library and just putting books wherever you want, or arranging them in a proper, order. The moment you ask me, give me a book based on something with S, I know I just need to go to that section and retrieve it. It is more easy for your brain to, allocate resources and get that faster. But when you do everything rather randomly, that's the reason, every chapter, if you observe, I give you steps to draw an FBD, steps to solve an equation, steps to solve a work per energy problem. You have that steps. What you need to learn is that. So in work per energy, it is always about visualizing how does the final situation look like. There, now you got initial and final situation. Initially, your velocity is 0. Finally, your velocity is 0 because you said minimum. You're just about to lift off. The velocity has just become 0. Conserve energy, state 1 to state 2. Can you try from here? You got a minute or two. Now it's just a matter of writing equations. Physics part is actually over, the major one. Try, you got a minute. Anyone confused with what happened here, please ask. There should be a kind of an analysis. What's happening? Okay, this is what happens after this. This is what happens after this. This is the reason this happens like this. If you don't ask yourself these questions, if you just write it like, scribble it and finish it off, you will have a problem. This is what you did in school. You just used to write off the answer without knowing what the hell it is. It was not necessary. Doesn't work that way. And it's not only about JEE. When you go ahead tomorrow, go to any engineering college, you get a job, you do anything. This is how you are supposed to think. Just think about it. You have 2 job offers. One company, let's call it anything. X is offering you certain salary, Y is offering you double salary, but it is in abroad. And if you don't have any brains, you'll just go for that abroad thing without thinking. If you have some brains, you'll sit and start asking yourself, okay, India's salary, I'm getting around, let's say 30 LPA. Abroad, these people are saying I'll pay you 1.5 crores. It looks awesome, 5 times salary, right? But what are the growth opportunities? What kind of company it is? What does it do? Does it offer me more future? You need to think 5 years down the line. If I do job in this company, will it give me the growth? What if this is a company, right, which is something like, Facebook? It looks great, but Facebook is dying. How many of you use Facebook? Right? No one uses Facebook. But imagine this is 30 LP in Google India. Maybe there's an opportunity. If you're in Google India, if you work here for 3-4 years, maybe then you can go to abroad also. And that is one. It's not only about the company. You need to think about a lot of opportunities. And what about the opportunities? Like, what about the cost of living? 1.5 crores na newspaper mein dalte. It looks very awesome. Most of it is bullshit. This 1.5 crore, right, also contains something called stock options. That means the actual salary is something like 80 lakhs. They'll give you something like 60-70 lakhs of stock options, which you can sell only after 4 years being in the service. But they will mix everything and give you. And the college also likes to hype up, na? So newspaper mein dalne mein acha lagta hai, 1.5 crores karke. Oh, 1.5 CR, maybe there's something called allocation charges. Matlab, when you're shifting for the first time, they'll give you some money. वो second year से नहीं आएगा. And after doing this much, I have one of my friend in New York. So I think last year when we were talking, he was saying, "अरे यार salary दिखता बड़ा है, hopeless it is करके 35% tax he pays, straight cut 35%, $3,000 per month he pays for rent in New York, food, electricity bill, that this thing will be another $1,000 per month." He says, "यार कुछ बचता नहीं है. If you don't make your own food, if you don't live little modestly, you won't save any money." If you save modestly, you can save. Like he says, like, I save around 30-40 living modestly. But if I try to live a luxurious life like India, you're gone. You will be in debt, even with 1.4 crore salary. That's the reason in US, if you see now, people, they don't stay in actually New York. They go to New Jersey. New Jersey is a rural area. There the taxation is less. It's I think 20 to 25%. But New Jersey to New York is 2 hours ka journey. So people actually travel all the way. Now just imagine, people ask you, where do you stay? I work in Mumbai, but I just live in, Kapoli or Karjat. How does it feel? So it is like that. हमको पता नहीं है ना, for outsiders it looks like New Jersey, oh, US करके. But if you go and tell people I'm staying in New Jersey, they look at you like, oh, you're a Kapoli guy. You getting it? So it is kind of like that. Kapoli, Karjat type. So ऐसा हो जाता है. This guy finally, my friend got irritated. He shifted to Hong Kong. I said, why? What happened? He said, yeah, living expenses the same. At least Hong Kong, I can roam around more, and India is more closer. Now he's there, Hong Kong. Mein. We do play games, so we are in contact. When he's in US, so night it is like what? We used to come online at night 12 o'clock. I am awake in the afternoon 12 o'clock. We used to play games. We used to play Age of Empires and Counter Strike. We still play, but I think 2 months back he got married, so we are not playing now. देखना पड़ेगा. नहीं, there is one more friend in New Zealand. This guy was a civil engineer at IIT Madras. He got into Uber ka, this transport ka algorithms he writes. Even though he's a civil engineer, he writes algos for Uber services, like what is the fastest route, all that stuff. So now he shifted to Hong Kong. The timeline has become a little less. So I have to wake up 7 o'clock in the morning Sunday to play. So yeah, we do have problems, but okay, works out. So how do you do this thing? So you need to think. If you blindly just put everything, maybe you'll survive now, but later on you will get slaughtered. So how do we write these equations? Seriously, 11th and 12th is a good opportunity for you to think. You ask all these IITians now, what's the best part you learned in 11th and 12th? They say, yeah, we started thinking in a different way. Because school doesn't give you that kind of opportunity to think. And most people love physics because of that. You can just take bloody one problem and you can play around 10 different scenarios with it. That's why most people's favorite subject is physics, at least in the top 5,000. So how do we do this thing? So state 1 to state 2, I will choose my natural length as reference. You can choose anyone as reference. Solving is a little bad. I don't think answer is mg by k, but so state 1, energy in state 1, I'll write down here. Potential energy minus mg y plus x1. Spring potential energy half k y plus x1 का whole square. Kinetic energy 0. Gravitational potential energy, you're above the reference line, mgx. Spring potential energy half k x square. Kinetic energy is 0. This is the energy in state 1 and state 2. Equate them. Minus mg y plus x1. x1 is mg by k plus half k xy plus x1 square. So y plus mg by k whole square is equal to mg xx is again mg 2 mg by k, na? 2 mg by k plus half k x square is 2 mg by k ka whole square. Brute force now. This is just brute force. You have to simplify. There's no way out. Minus mgy minus m square g square k. This guy would be half k y square plus half m square g square by k. And this will be k. They will get cancelled. mgy. This will be 2m square g square by k plus 2m square g square by k. mgy gets cancelled. It's not really that bad actually. So half ky square, shift everything that side. That is 2 to 4, 5. 5 minus half, that is 4.5. So 9 by 2. M square g square by k. 2 goes off and y will be 9 by 4. 3 mg by 2k. I hope I didn't go off the calculations. 5 minus half. 2 cancel होगा ना, 3 mg by k. That's your answer, everyone. Y is 3 mg by k. Please check the steps. How do we do this? Clear? Look at the calculation. Calculations, there's nothing there. You just have to put and number crunching it. And this is one more mistake that I observed in some of you. You guys see the question, you say like, "Haan, mujhe aata hai," and you don't solve the question. You have to solve till you get the answer. Don't just make an assumption, I know how to do. So what is happening with that? When you go to the exam, you see a question, you get irritated to solve the question. Because what you think, because you made a brain habit, na, if I know how to do, there's no need to do. That's what you taught your brain. And suddenly in the exam, what happens? When you have to solve the question, your brain feels like, what the hell is this? Why should I solve? I won't solve it. You know how to do, na? Enough. No need to bubble it. See, what is the problem? Telling you again, whatever you do, you are teaching your brain the different stuff. You need to be very clear what you're putting in the head. Clear with this? Any doubts? All got this? I don't know how you guys got 4 mg by k, and mg by k was wrong though. 4 mg by k was a goofed up thing. Either I messed up or you guys messed up. Please check where it went wrong. All clear with this? Next one. It's a good question.
So can you go back for a minute? Yes, sir.
We have a cylinder here. Hollow smooth cylinder. Inside we have a block M. And this whole cylinder started accelerating with A. Is placed inside and the cylinder is accelerated with constant acceleration A. Find the maximum angle deflected, meaning because you're accelerating, what will happen? This guy will actually start going up. Cylinder is accelerated with A. Find the maximum angle, max theta, the block climbs. There is no friction anywhere. Gravity is there. Is accelerated with the constant. Is the question clear? Ever did this with your friends or siblings? Put them in a drum and roll it? Never did that. You guys are all good people, right? ये water का बड़ा plastic drum होता है ना to put water. I and my sister used to play like that. So I used to put my sister inside and used to roll. And I used to do that. My sister is little weak to push, na? So what I used to go inside the drum and we used to have a small incline kind of thing. So I used to sit inside the drum and I used to roll. It was a game we used to play when we were kids. And one thing, you'll notice when you rotate very fast, na, you'll actually go and stick to the wall. You will rotate with the drum. You won't fall down. There is a ride like this in Zorb Ball. Yeah, they put you in a ball and they throw you from the cliff. It's like a transparent ball. Yeah, kuch seen somewhere? I think it's called Zorb ball or something like that. I don't know the name properly. It's like you have an opening here. You can go inside, and they put you inside and just throw the ball, and the ball starts rolling, and you're inside there. You can do this on the beach also. You can put them the ball and they put you on that beach. You can roll yourself and go. Something of that sort. That's what happens when you don't have Instagram, internet, YouTube shorts, and all this stuff. What to do to keep yourself entertained? Again, I'll tell you one thing now. Every generation is distracted. You guys are not special. But the only thing is, your generation has more options to get distracted. During my time, how do we get used to distracted? No one wants to study. Your generation, my generation, your parents' generation, no one wants to study. Humans are not created, we are not designed to study, sit and do calculations, cylinders, rolling, bullshit. We are not designed for that. And that is the whole point. That is the reason most people won't do it. And that is quite natural. But what you're doing is you're going against your human instinct and you're trying to prove yourself. That's what makes you a better person. That's what makes you different from others. So the only problem with your generation, right? Too many distractions. You have many things to get distracted. During our time, if I want to get distracted, what to do? Go down and play with the friends. How long will I play? 1 hour, 2 hours, 3 hours? I get tired now. I come home eventually. Abhi now I'm bored. What to do? Chalo book open karte na. Abhi घर आ गया तो mom will keep jumping and shouting. So you have to open the book. So we used to open the book. But what you guys can do, like you can open the net and say I'm studying, and you watch something. So you can actually fool your parents in a better way than what we could have done. So that way you have better options. Let's get this thing. At least my observation, I have seen kids from 5 years back, and now you guys have changed a lot. Tan inverse 2a by g minus a square. Okay, we have one answer. Others try. 5 years back, parents used to call and say, "Sir, my kid is not studying. Please talk to him." I said, "Okay, ma'am, I'll do that." Now parents call and say, "Sir, my kid is not studying. Please talk to him, but make sure don't tell that I called." Huh? So that last way, that one extra word is coming now. I feel like, yeah, then who is the boss in the house? The kid or the parent? Chalo, how to do this thing? Remember, I told you today only. Just now I told you something is going with constant. What do you do? Stand on that. Stand on that. If something is going with constant acceleration, constant, just go and put the observation on the cylinder. Put a pseudo force and solve. Get it? You got a minute. It's an easy now. You hear the word something is going with constant. Think of that's the first thing you should think of. Let me go and put an observer on that frame and see how it looks, and then start solving. Tan inverse G by A. No, that's the thing you have to be careful there. The block won't stop at equilibrium. So if you keep your observer on this, you will see a pseudo force, MA horizontal. Now be careful here on this part here. This is a mistake most people do. This is MA. This is MG. If you take this angle to be alpha, this components will be mg sine alpha and mg cos alpha. So when these two become equal, mg cos alpha is equal to mg sin alpha. MA, sorry. MA cos alpha is mg sin alpha tan alpha A by G. At this point, body has maximum speed. This is your mean position. It won't stop here. Think about it. Pseudo force was greater than mg till here, so it was gaining speed more and more. It won't stop here. It will continue to go further. This is your mean position. This is the mean position. This is not the answer. Most people do this mistake. So then what we do here, let it go till this position here. The block will come till here. This is the horizontal distance traveled. This is the pseudo force. Do you remember we did a question? The work done by the force. This question it was. This one. If the force is horizontal, the work done is force into horizontal displacement, isn't it? Force into displacement in the direction of the force. So even though this is going on a curve, the work done by the pseudo force will be pseudo force into the horizontal distance. This is r sine theta. And what is this height here? This guy is r cos theta. So this will be r into 1 minus cos theta. So you end up with work done by pseudo plus work done by external force is change in potential energy plus change in kinetic energy. Work done by pseudo force is ma r sine theta. External force is 0. Change in potential energy is mg r1 minus cos theta. Initially, finally, it is at rest. M gets cancelled, A gets cancelled. This guy would be 2 sine theta by 2 cos theta by 2. 1 minus cos theta is 2 sine square theta by 2. You end up with tan theta by 2 is equal to A by G. You get theta is equal to 2 times tan inverse A by G. You get double the angle of equilibrium. Be careful. You want tan inverse A by G is the equilibrium angle. You always get double. So in this question, that's the main thing. Just be careful. At equilibrium, you won't stop. At equilibrium, you actually have maximum speed. You'll continue to go further with faster and faster. Please look at the steps. Anyone not clear with the steps or not convinced with anything, please ask. Clear? Next one. Can I turn the page? So be careful with these things. Huh? The same question, right? You could have asked like this also. There is a pendulum here and someone is applying a force F. Find the maximum angle deflected. Exactly same story. There is no difference. It's F का place में MA डाल दो. You'll get the same answer. Clear with this. Next one. This is a good one. It's a standard question, but I really want you to know what happens here. You might be thinking like, spring block, इसमें हो जाएगा. Just to give an example, I was recently teaching your seniors. Spring block, I was teaching them a chapter called electromagnetic induction, EMI. And we are doing something called an AC circuit. So there was something like this L, L, C, and all. Don't get scared. If you see, right, even in electricity, you can solve problems with spring and block. So you will see a lot of resemblance, For them, there's a last but one chapter. But yeah. So the springs, blocks, the analysis, what you're doing, it is going up, it is coming down, it has maximum speed. The analysis is quite important. This question, you'll get a better idea. So we have a block M, K, the spring is a natural length. Block is released from rest, gravity is there. So initially you're holding it and then you just left it. So what will happen? Block will start oscillating now, up and down. The question is, find the maximum speed of the block and maximum elongation in the spring. Find max speed and max elongation in the spring. Let's get this. Anyone confused with the question, please ask. Always ask, don't hesitate. You're not getting something, ask. If you're not getting something, maybe it is my fault. It is not always yours. Ask, get it cleared. I'll explain. If you ask me something like why, spring force is K into X, then I'll punch you. That you should have revised the notes. So ask something very dangerous doubts. You can ask silly doubts also, nothing like that. Ask. Main thing is that. If you don't ask, you don't get. Isn't that what we do when you go to temples or any religious place? We keep asking God, God, give me that, give me that, give me this, give me that, everything. Poor God, what will you do? What is the maximum speed and the maximum elongation in the string? Take a minute or two, then I'll show you how to do. Any answers? Root 2. What is X-ray? God, Aryan. Oh, X is elongation. Great, but what is the value of X? If that is the case, I will say, what is maximum speed? V. Okay, na? Why to work so hard in life? Just say V, na? What is maximum elongation? X. What is the rank in JEE? Unknown. You can just get any options there. You should give answers in the variables that are given. K, M, G. But there are only 3 variables. You can't create a new variable and give answers in that. Monica, you says mg by k. That is a trap. Remember, just now I told you. At equilibrium position, it won't stop. You wrote kx is equal to mg directly again. Don't do that mistake. If you think from that, it will be double of that always. Yeah, it doesn't stop at equilibrium. Never write kx is equal to mg is maximum. That is only if you catch the block and gently release it, it will be that. But if it is oscillating, it will be always double. Yeah, right. Adrit, Anusha, Venkatesh. You guys got the elongation. Get the speed. Right, Palaksh. Get the speed. Let me show you the analysis. What is happening with this block? And listen carefully. More than the actual problem, I'm more interested in this part. What is happening with the block? And again, this thing will repeat in the later on chapter, centromers collisions. So we have a block here, mass m, k. This is a natural length. Forces on the body, mg. There's no spring force. Kx is 0. So this block is going down with an acceleration g. Then next moment, because of and velocity is 0. Next moment, you will fall down a bit. Kx, mg, but the gravity is still greater than kx. The block won't stop. It will accelerate. It will also have velocity downward. Block will continue to move. The spring will stretch sufficiently kx and mg. We get kx is equal to mg. At this position, acceleration becomes 0, but the speed of the particle becomes maximum. If you see in this scenario, the A and B are in the same direction, so it is speeding up. At this point, you get a maximum speed. Then it will not stop now because it is a maximum speed. It will continue to go further. This is mg. This is kx. Now the spring force kx has become greater than mg. Acceleration is upward, velocity is downward. Now it is slowing down. That is how I know the case 3 is actually maximum speed. Because see, here it is speeding, here it is slowing, but this should be maximum. You reach the maximum value. What is that answer, Abhinav? You got a very good answer. Plus or minus 258 by 852014. You
So
must
that
have
I
typed down the calculator.
made by mistake. I was cleaning the keyboard off when it came.
Yeah, but that would be an interesting answer.
Sorry, sir.
Nah, don't be sorry. So what? You guys say sorry so easily there. First of all, don't do goof up things and don't say sorry. Next one. Then what happens? I'm just wondering. You got a very nice answer. So this is n. Now this will continue to go further, right? So this will finally stop. At this point, this is your maximum elongation. This is kx. This is mg. Kx is greater than mg. So the block will start going up. So when the block goes up, this is kx, this is mg. Now you're also having acceleration also, velocity also. Then again you come to the mean position. Acceleration is 0, but your speed is maximum. So there are actually 2 times you get maximum speed. And then you get kx, then you get mg. But this time again, mg became greater than kx. So your speed is up, but acceleration is down. And finally, you come back to the initial state. This is the full cycle. This is your state 1, state 2, state 3, state 4, state 5, state 6, state 7, state 8. And comes back to state 1 again. So this is how the whole cycle keeps on going. It will never stop. Do have a look at this. This is what is happening with the whole system there. Now, in this states, we are interested in state 1, state 3, and state 5. Because state 3 may you're having maximum speed and state 5 may you're having maximum elongation. That's what you asked me to find. So exam may you won't do all this. Exam may you just need to know state 1, 3, 5, how they look. But this is just an analysis. You know what is happening with the whole motion there. Please have a look at this properly. Ask me any state that you're not clear or not convinced what is happening. Do check it out. And then if you're done with this, then the next part would be you just need to define your states now again clearly. State 1. State 3. State 5. This was the natural length. This is x is equal to mg by k. At this point, the speed is maximum. Initially, velocity is 0. This is the maximum elongation, and v is 0. Gravitational potential energy, 0. I'm taking the natural length as a reference line. Spring potential energy, 0. Kinetic energy, 0. Everything is 0 in state 1. State 2, gravitational potential energy, minus mgx. Kinetic energy, half mv max square. Spring potential energy, half kx square. State 5, gravitational potential energy, minus mgx max. Spring potential energy, half kx max square. Kinetic energy, 0. So energy in state 1 is equal to energy in state 3. If you equate these two, 0 minus mgx, that is minus m square g square by k, plus half mb square, half kx square is again m square g square by k square. You end up with root over k m by k g g square, let it be g into root over m by k. No. Looks right. V is equal to root m by k. That's your V max. You want maximum elongation, state 1 and state 5, 0 minus mgx plus half kx square. X will be 2 mg by k. Please check your answers. That's how you do. Like I said, this is how you do, but this is a complete analysis what is happening with the problem. Do have a look at this. Any confusion, please ask me. 2g by k root mv max. No, no. This is m square g square. This is half m square g square. It will be half. 2 will cancel. 2 nahi aayega. Right only. Check your calculations. Any doubts on this step, please ask me. All these old lectures read before work power energy, meaning up to circular motion and everything, will be uploaded on a YouTube channel and you'll get access on Sunday. So whatever old chapters we have done from calculus and all that, recordings and all will be available. Now, ideally speaking, you can go through the notes, something you didn't get. Don't get too obsessed with this watching videos and YouTubes and everything. I'm just keeping them just in case. You have a doubt or something, it is always better you go through the notes and ask and get it clear. That is fastest. If this particular concept you need, you can go and refer. Don't sit with the 2 hours of full video watching and wasting your time. Because frankly speaking, physics mate is more of solving questions. There is nothing like you read the chapter 10 times, you won't understand anything. But you'll be getting access from Sunday. Clear? This is clear. Any doubts on this? Next one. Next one. Let me do. I did that. So we have 2 blocks here. This is K. This is mu, but this block is smooth. And someone is pushing with F. Initially, it is a natural length and rest. Find the minimum force if 2M block just moves. So you're pushing the M block with the force F, so what will happen? Spring will compress. And that spring will push the 2M block. So find the minimum force F so that the 2M block just moves. Get it, this is an easy one. How do we do this? Now, someone has a doubt like, sir, how do you know maximum speed always occurs at equilibrium position? Listen to this carefully. We can prove this mathematically. Again, the statement, why does a particle always have maximum speed at equilibrium position? Okay. Now, let's say velocity v is a function of some time or something. Okay. Tell me one thing, for a function, how do you find maximum minimum value? What is the first step that you do? dv by dt is 0. What is dv by dt? Acceleration. If acceleration is 0, what position is that? Net force is 0. Equilibrium, no? There. That's how you can prove mathematically that equilibrium position, you always have maximum speed. Doesn't matter what it is. If someone asks you find the maximum speed, find the equilibrium position. That is where you get maximum speed. Get this, everyone. This is a good one, easy one. Mu mg. Okay. Might be right. Let's see. Two mg plus 1 plus mu. Wow, that is weird. That is wrong value. Any other answers? We have one answer so far. Again, so just think about it. This was your initial state. This is 2m. The block must have moved till here. So let the block move a distance of x. So if you want the 2m block to move further, the spring force Kx should be equal to the friction 2 mu mg. So basically x ka value will be 2 mu mg by K. This was your state 1 and this was your state 2. And you're applying a force F. The work done by external force is work done by, what work done? Change in potential energy plus change in kinetic energy. The work done by the force is F into x. Change in potential energy is half kx square. Height is not changing, so there's no gravity. Initially, finally, velocity is 0. You just stop. So there you are done. So x is equal to F is equal to half kx, which is mu mg. You just need actually half of the force. Again, you might ask, sir, why is this happening? Because you won't stop at the equilibrium position. Remember, you always go double. If you apply 2 mu mg, the block will move when at the equilibrium position, but it won't stop there. It will go further. And I'm asking you minimum force. So if you apply mu mg, equilibrium position will occur somewhere here, but it won't stop. It will go further and stop here. So at this point, this 2m will just move. It is ready to move. Please check it out. Easy one, but this is a kind of a question at a mains level. And most people write 2 mu mg and come because unko lagta hai if kx becomes, they think this should be the natural length. This should be the mean position. Because if this was the mean position, your speed will be maximum. You won't stop here. You'll go further. Means you have generated more force more force than required. That means F is not minimum. I hope you're getting the meaning of the statement. If this was the mean position, you will have maximum speed. Means you won't stop here. You'll still go further. Means you are generating force more than required. That means the force you applied is not minimum. You applied more than required. If you just want to stop, just want to move, this point should be this thing. Put it up. Clear, everyone? Next one. Easy. Any doubts? Next one. Easy one, but a good one. We have x is equal to t square by 2 plus t power 4 by 4. This x is the x coordinate. Mass of the body is 2 kg. Find work done with the force in 2 seconds. U of x potential energy is x power 4 by 4 minus x square by 2. This is your potential energy. Total energy is 2 joules. Total energy of the system is 2 joules and mass is 2 kg. Find the maximum speed of the particle. Sure, let's get these two. $156. Nare. Quite a weird answer. How do you do this? I gave you position as a function of time and I'm asking you work done in 2 seconds. These are proper mains level questions. First one, you will get it in 2 steps. 2 steps you will get it. Think. Right, Arjun. नहीं आर्यन, नहीं अद्रित, इतना बैड नंबर्स नहीं है रे, अच्छा आंसर आएगा. Those 2 lines. Think. There's something there. I know what you guys are trying to do. You guys are trying to find force by differentiating 2 times mass into acceleration. Then you're trying to integrate integral f dx, and then you're trying to put 0 to t. Someone got 156. People are getting 156. That means you guys are doing something to get the same number. Listen to this. What is work done by all forces? Work done by all forces is change in kinetic energy. That is half m v final square minus half m v initial square. So what is the velocity here? Dx by dt. That would be t plus t cube. At t0, velocity is 0. At 2 seconds, velocity is 1 plus 2 plus 2 cube 8, 10. So therefore, this will be half mass is 2 kg into 10 square, and that is 0. 100 joules. Make sense? Differentiate, get the velocity, find initial velocity, find final velocity. Work done by all forces, change in kinetic energy. You're done. How are you guys getting 156? But 2-3 people got the same number. What did you guys do? Anika, what did you do for 156? Niranjan? Anyone? No, I know it is wrong, but I'm more interested. Like 156 looks so interesting number. So got acceleration multiplied by, but that would give you force, right? That doesn't give you work. And then you multiply it into 2 again, yeah? Something displacement. Forgot to multiply with displacement. You can't write force into displacement. That is wrong. Force is not constant, na God. A is changing. F is not constant. You can't do that. You can't write force into displacement here. F is changing. Even if you want to do integral F into S, you should do integral F dx. Get the B part. That is wrong, Arjun. I know what you did. Get the B part. Potential energy is x power 4 by 4 minus x square by 2. Mass is 2 kg. Total energy is 2 joules. Find the maximum speed of the particle. I hope the first one is clear. Anyone not convinced, please ask. Someone gives you x as function of time t. That's how you do. Someone got disconnected. Who is this and who is missing today? Mehan and Udyan. Mehan is not well. Udyan is traveling. Fair enough. Any answers for the B part? Look at this. We know total energy is potential energy plus kinetic energy. So you want kinetic energy maximum, then potential energy should be minimum. Agreed? If potential energy is minimum, then kinetic energy is maximum. U is given by x power 4 by 4 minus x square by 2. The mistake you guys are doing is you are thinking U minimum is 0. Who told you? How do you find maximum minimum? Du by dx, which is x cube minus x equal to 0. We get x is equal to plus or minus 1. Double differential d square u by dx square. We get 3x square minus 1. So if you put x is equal to 1, we get double differential will be greater than 0. So this is minima. So at x is equal to 1, u is minimum. How much is that? So U minimum is 1/4 minus half minus 1/4 joules. That is the minimum value. It is not 0. So going back there, so total energy is U minimum plus kinetic energy maximum. So total energy is 2. This guy is minus 1/4 plus half mv square, but m is 2 and v max square. So you end up with V max is equal to 2 plus 1/4 is 9/4 ka root. That is 1.5 meter per second. Check. Is that making sense, everyone? So the main trap here is U minimum is not 0. For this particular function, the potential energy was actually negative in the minimum value. If you take U minimum is 0 and 2, you will get how much? 1, I guess. Clear? That's it. This question is really not tough, but this is what I was saying. This is the kind of questions you can expect in mains. This is a good question. Even at a mains level, this is a good question. Out of 25 questions, you can expect something of this sort, like 10, 12 questions. If the paper was moderate to hard. Paper is easy, maybe you'll find 6 questions like this, 6 to 7 questions out of 25. Advanced math, this will be an easy one. Clear with this? Any doubts on this? This will be the homework. Again, try and come. It's a good problem. The reason why I give you this thing is it will take time. So if you see the first question, we discussed almost for 25 minutes. It took time. It is a worthy question, but when you do analysis and think everything, so spend some time, on doing the homework question. Then it will be more easy when I explain you. If you don't try and come, you are just like listening to a movie. It doesn't make sense. So we got a big block here, M. We got a ball here. We got a hinge like this. So this is some sphere. Mass is small m. Initially, the whole system is at rest. It's a light rod. And the length is L. And all surfaces are smooth. Now, when I push this, someone just gently disturbed it, and this is what happened. This rod actually started swinging, and you just lost contact. This happened at 60 degrees. So at angle 60 degrees, they lose contact with each other. Since after this block will go here and this will just fall down. Are you getting how it is? The big block is going because this guy is pushing it. At one point, they both lose contact. At 60 degrees, they lose contact with each other. This happens for a particular value. Find m by m ratio. This is a proper advanced question. It's a pretty good one. Do have a look at the question. Ask me if you're confused here. This you will try, and the next class, first thing we'll be discussing this. So we got a ball of mass M, rod is light, length is L, and it is touching there. As it is going, this thing will start going to the right, and at one point they lose contact. They don't touch anymore. So that happens at angle 60 degrees. Find capital M by small m. I hope the question is clear, everyone. So do try. Next class when we meet, we will do few more problems on this, and then we'll start off with vertical circular motion. Next week we'll wrap up the chapter. And then we will start off with, we'll see, either with center of mass or we'll start off with ray optics. One of them we have to start. We will go ahead with the portion. And the last week for the major test, maybe I'll not take a class on Friday that week, but we'll have classes as usual till Tuesday and Wednesday. Okay, so with that, we'll wrap up for the day.